Good morning, I'm Mallory Crow. I'm going to be presenting today. If you have any questions, we'll be doing that at the end. And I'm sorry if I go quickly through anything, but I want to make sure we have time to answer everything. And the final report will be up, so more in-depth detail about this project will be available. First off, we just want to thank ODOT research team and our technical panel for all their support and help on this project. And let's get started. So obviously snow and ice management is one of the single largest expenditures in the maintenance budget for ODOT. So anytime that there's an opportunity to minimize the cost while maximizing efficiency through new pieces of equipment or whatever, ODOT's interested in evaluating that to determine if it's worth their investment. Ashtabula County and ODOT had also already had a tow plow, and they did their own pilot study. They really liked it, so they wanted to gain more knowledge on this new technology to see if it should go into other areas throughout the state. So for this project, originally it was for Portage County only, but since Mahoning County had also purchased a tow plow and Ashtabula already had one, we wanted to expand into other areas to gather more data to see what it's like in different areas of the state. So from here you can see the garage locations, and then the 3 counties are in green that the study took place in. Also, Mahoning County did go all the way down State Route 11 into Columbiana County. They kind of helped them out too throughout the winter season. All right, hold on.
It should recycle.
Okay. All right, so that's where the project took place. So we compared it to a standard truck. Most of ODOT's standard trucks are either single or axle tandem dump trucks with either 11 or 12-foot plows. There are some 14-foot plows, and some may also have an additional wing plow, which adds an extra 5.5 feet. So for this particular study, it was the truck on Portage that was opposite of the tow plow was a tandem axle truck with a 14-foot plow and a wing plow. So we really were putting the tow plow up against the kind of biggest, baddest standard truck you can kind of get out onto the road. So again, here's the comparison. So you can see in the picture one of the wing plows expanded. They only really put the wing plow out into the middle of the lane when they're doing gang plowing like this, due to the fact that it's hard for the public to see and safety hazard. So there were 2 sides to ISA, Interstate 76 in Portage County. One was treated by one of the trucks, whether that be the standard truck or the tow plow, and the other side was treated by the opposite. They switched throughout the season, which we'll get to when we talk about the Bluetooth nodes. So it's important to understand what the tow plow system is. This figure can be found on Viking-Cives website, and it kind of just details some of the specs of the tow plow. You need at least a tandem axle truck with 350 horsepower engine to pull it, or it's recommended, or you might have some issues getting the tow plow up and throughout the various terrain that you have. The tow plow units that ODOT purchased were equipped with a hopper and a brine tank, but you can do your own kind of configuration, whether you just want brine tanks or whether you want 2 hoppers. It clears a 25-foot path in when you're joining it with the tandem axle dump truck, as you can see from the figure, and it operates safely from 30 to 40 miles per hour. In some places, I think they can drive it even faster, but that's what we saw throughout this study. So when we're collecting data for this project, we looked at 3 various types. We looked at the weather, which consisted of looking at NOAA hourly snowfall data, and then from there we can determine weather severity for each storm event that the trucks were out in. The next one would be the vehicle speed, so that would be the public's vehicle speeds, the level of service of the highway. So we used a Bluetooth node system along 76 and in Portage County to compare the side that the tow plow was treating to the side that the standard truck was treating, and to determine the level of service provided by each one of those trucks in various weather events. And then we looked at, obviously, the snow plow trucks themselves. The tow plow we equipped with a video system that recorded different angles of the tow plow so we can see how it's being used throughout storm events. And the standard truck was equipped with a GPS AVL unit, and we also verified that information with the 661 forms that the operators fill out during storm events. that was to determine how each truck was utilized. So when we start with the weather data, we use the NOAA data. It was the one website that provided us with the precision we wanted, which was hourly snowfall data. We didn't want it to be daily or weekly because that wouldn't really help us with this project. So we found remote sensing centers, stations that they have closest to where the tow plows were being deployed, and those are the snowfall data that we used. We would review the total cumulative snowfall during that event and the peak hourly during that event to categorize it into one of the 5 groups, which would be no snowfall. So that would be if the trucks just went out and they were expecting snow and nothing happened. Trace snowfall, which is less than like 1/10 of an inch, and then you get into the light, the moderate, the heavy. The details of those categories can be found in the report. Here's a sample of how we categorized what a weather event was. We basically allowed for there to be 1 hour of no snowfall, and we added an additional hour at the end to allow the trucks to still clean up from that snow event. So from this figure on the left, you can see the hours from this date from 7 a.m. going into the next day at 8. And you can see that there's one event earlier on the top of the table that's just a 2-hour event. And then at the bottom, you see a larger event. So those would be considered 2 separate events and be categorized differently. You can see from the bar chart on the right, this is our distribution of what kind of events we saw throughout the study. So a high number of light events, and then moderate, and then you get the trace events, and the heavy and the no snow are fairly low, just that whenever the no snow, like I said, when they go out and they don't necessarily need to. Doing treating or something, making sure it doesn't ice over. Next, we're going to look at the vehicle delay data. So we wanted to obviously compare the delay that's caused by the tow plow and the standard truck and the level of service on those 2 segments. We used Bluetooth technology. They were placed along 76 in Portage County. You can see here is a list of what the nodes consist of. And they don't pick up, obviously, every vehicle. They're just picking up vehicles that have Bluetooth-enabled devices on them, but it allows us to see the trends of the roadways at various times throughout the events. And the Bluetooth nodes are placed out in the field. They were placed out the year before also, so we had good baseline data to compare, so we could see what the speeds were during any type of weather. And they are maintained weekly. The batteries need changed out. So here's a little figure of where they were placed and what we're considering the western side and what the eastern side of the Interstate 76 are. So between each time a vehicle passes one of these nodes with a Bluetooth-enabled device, it timestamps it, and then from there we can calculate how long. We have a fixed distance between the nodes, and we have the timestamps. We can calculate what the speed of that vehicle is. And we can do that throughout the whole interstate in Portage County. And State Route 44 is kind of the split for the eastern side and the western side. So when we looked at the delay analysis, we were comparing the expected time travel, so we used that baseline speed, to what the actual time traveled was during the snow event. We looked at 3 different categories for the storm event for this one, and we didn't, because you can't tell what the future snow is going to be, we used just the previous 4 hours, and that's how we categorize the storm, which is different than the overall utilization of the tow plow storm categories. So here's a list. We have light, moderate, heavy, and we looked at 3 different scenarios, which can be seen in the figure. So the first one is just looking at each individual node and the time it takes to travel between them. The second one is looking as the trucks exit, looking at the time as soon as the trucks exit. And the last one is looking at the standard truck delay once the tow plow was gone. So once one of them was gone, which I believe truck B. Okay, so the delay after each one was gone. I'm sorry. So the expected time travel based on the baseline data, the western side was fine using the speed limit of 65 miles an hour as the expected time traveled, where the eastern side we did notice that it was slightly higher at 66 miles per hour, so that's what we use to determine that expected value and the delay. So when the tow plow is treating 2 lanes and the standard truck is treating 1 lane in light snow, there's more of these graphs and more of these delay relationships provided. I just wanted to give you guys some. We do see for the first, the blue line, the colors a little bit. The solid blue line is the tow plow in light snow 0 to 4 minutes after treating. So after it's treating 2 lanes, you can see that the cumulative delay line is a little bit slightly higher than when the standard truck, which is the dotted red line. So you could see like you expect to be about 10% of the cumulative delay is around, you know, a minute, between 1.2 minutes for tow plow. That's kind of how you're reading these graphs. The equations at the top are just giving you the fit equations. So we do see that the tow plow, when it's treating 2 lanes, because there's no passing lane, does cause a delay more so than the standard truck. This is when their tow plow is treating 2 lanes in the standard truck, but this is a heavy snow event. So you still see the delay, but the standard truck also has somewhat of a delay. And that's just the 0 to 4. Once you get into the 15 to 19 minutes later after treating, they're pretty similar. So it doesn't take much. The immediate delay is higher for the tow plow, but once it gets a little bit later, 15 to 20 minutes later, the delays start to become very similar. And then this is after the trucks exit the highway in heavy snow. You can see that the delays are all very similar, whether it's 0 to 4 minutes after treating or 15 to 20 minutes after treating. So there is higher delay with the tow plow during most storm events, but once they leave the highway during heavy storm events, it's the same, whether it's the tow plow blocking 2 lanes or not. There's more configurations as far as tow plow treating 1 lane and shoulder, and again, there's the moderate snowfall delay charts also available in the report. So the standard truck data, we said we use the GPS AVL, and you can see a picture of one of the modems and a screenshot of the 661 reports generated from this system. And we use this to determine the utilization of the standard truck during each one of these storm events. So whether they had their plow down or plow up, or whether they were salting or not. And that's all going to play a factor once we get into the cost analysis and the utilization of the trucks during different storm events. The tow plow, we use the video data. The top left picture are some pictures of the cameras. So we have a driver's side camera, the rear camera looking back, which usually got snow covered, but was more for the operators anyway when they wanted to turn around the trucks. The passenger side camera, which kind of allowed us to see if the tow plow was deployed or not, and whether the blade was up or down. And then the front camera, which allowed us to see the front blade and what the traffic and everything looked like in front. The below it is a picture of what the angles actually look like on the video, the DVR that's recording these cameras, and what we looked at during our analysis. And you can see that there's time and dates and lat and longitude, so we can see where the tow plow is actually at. We also put lasers on the 3 tow plows, which are guidance lasers. They're meant for wing plows to let you know where the end of the plow is, so that before you get there, so you don't so you don't hit anything with it. They're meant to be stationary above the passenger side window and at a set angle to whatever it is, but since the tow plow can be deployed at any angle, Ashtabula decided to try it on Mahoning counties when they were doing some different things like upgrading the lights. They decided to try to make a rack that moved along with the wheel wells, and it actually moves as the tow plow moves out, so you can actually see exactly where the end of the tow plow is at any angle. And they liked it so much that they ended up making one for their tow plow as well. And at the bottom picture is one of the DVRs, which just is recording the cameras and has a hard drive that we would switch out every so often to download the data. So when we looked at the video data, we looked at front plow usage, tow plow deployment, and then from there, whether it was plowing or whether it was only salting. Through discussions with ODOT, we decided that if the tow plow is deployed and the blade is not down, it is salting. Everyone was pretty comfortable with that assumption. We also looked at the tow plow's position, so what angle was, or what lane the tow plow was in. And then obviously if the tow plow was not deployed at all. Here's a sample of one of the spreadsheets from the video documentation. The detail we went through was basically, we probably watched about 2,000 hours worth of video for the 3 trucks throughout the season. And anytime one of the things listed below, which is tow plow deployment, tow plow treatment, front plow deployment, they get on a new route or they change lanes. Anytime one of those was changed, a new data line was created. So we basically document what the tow plow is doing at all times throughout the whole season. When we get into the discussions of the results of the utilization of the tow plow, I want to make sure everyone understands what we mean by tow plow deployment. So here are some definition pictures to kind of give you an idea of what we're talking about when we use these terms. So tow plow deployed is the first one above. So obviously the tow plow is swung out at some kind of an angle, and it's being used with some kind of treatment, whether it's salting or plowing and salting. You can also see a picture of what it looks like in the video data. Below that is when it's not deployed, so it's directly behind the standard truck, not deployed at all, which you can also see in the video data. The tow plow could be used to be salting at this point, but we would consider that not being utilized because it doesn't need to be there for them to salt that road, that lane. Here's some of the position of the tow plow definition. So the top left is the shoulder, so it could be at some form it's pushing back the shoulder. It's pretty obvious to tell in the videos when they're worried about the main line and when they're doing cleanup and worrying about the shoulders. There's a couple different ways. It could be in the right lane, as you can see from the top right and the bottom left. It could be over a little bit into the median to make sure everything gets pushed over, or it could be more so in the right lane. But we would consider both of those right lane deployments. And then anytime it's on a ramp, it's a ramp deployment. So the overall tow plow deployment throughout the season, and this is for all of the counties combined, it's broken down by counties in the report if you would like to see that. So we're looking at, we did it by time and by mileage. So you're looking at 53% mileage. It was deployed to 47% not deployed, and the time being similar at 56 deployed and 44 not deployed. During the times that it was deployed, so during that 56, 54% of the time, this is what the treatment of the tow plow was doing. So 91% of the time it was plowing and probably salting, but we have no way to verify that, but it was being used to plow. And 9% of the time it was just being used to salt, which is getting, it's really, that's the way you would want to use it mostly to plow and salt, not just the salt. Tow plow position, so you see for plowing is the first part of the bar chart. So when it was plowing, this is the distribution of what lane. So you can see right lane is by mileage is 69% and by time is 66% of the time when it was plowing, which means it's not being used as just a cleanup vehicle, which was good. When it was salting, surprisingly it was salting mostly in the shoulder, but it was only salting 9% of the time. So that's overall not too bad. Give you guys a minute to look through that. I don't want to read off all the numbers. So when we get into the cost, we wanted to look at what the annualized cost of the tow plow versus standard truck was. We used a Monte Carlo simulation in MATLAB, which basically you set an average and a standard deviation for the variables used in your equation, and it will randomly do a random number generator as many times as you set to give you an overall average and with a distribution of what the results should be. We used utilization rates for each of the trucks by storm classification. So how much during each one of these storm events, on average, were these trucks being utilized? And then we also determined a tow plow to standard truck equivalency. It's just the tow plow can do what 2 trucks can do. However, it can't always be deployed and doesn't always need to be deployed. Therefore, we know that it's not an exact 2-to-1 ratio. So we wanted to determine, based on our observations through this study on these ODOT routes, what that truck equivalency was. And then obviously we were going to compare them. So this is a flowchart of the variables that we used when we wanted to look at annualized costs. So we wanted to look at annualized capital costs for each one of the pieces of equipment. The annualized factor, we had one set number for variable for those, which was 8 years for the standard truck and 8 years for the truck pulling the tow plow. However, through discussions with ODOT, they believe that we can get 2 truck lives for 1 tow plow. So the annualized capital, or the annualized factor for the tow plow was set for 16 years expectancy for life. And then we looked at what it costs per year. For the maintenance cost, so we looked at parts and labor. I know that we just kind of combined those into what they expected for overall maintenance costs, but that would include parts and labor. When we looked at the operational costs, we did the fuel cost per year and the labor cost per year. When we look at the fuel costs, we want to obviously look at what the price of the fuel is, and then we wanted to look at what the fuel economy was for each one of the vehicles when they are treating and when they're not treating. So we used real field data to determine that based on the 661 reports, what each one of them did, or what the average and what the standard deviation was for each one of those variables. Same thing with the speed of the trucks. We looked at if there was a difference between the speed of the tow plow versus standard truck, and when we looked at all the data, we got an average to be, I think, 31 miles per hour for both, so we just set it as 1. We didn't need to split it into 2 different speeds. And then hours per events per year, and then we looked at a utilization rate per storm type. For the labor cost, just the labor rate, hours per event, and events per hour, or events per year. Basically, if they get called in, whether they're in a standard truck or a tow plow, they're there for their shift. So it doesn't make a whether they clear their route faster, they're still there. So that was just set as one thing we didn't need to go into too much detail about for the labor rate. Here's a list of the variables again with what averages and standard deviations we used, along with the source of these variables. The utilization rates, excuse me, will be presented in another slide here. But if the source says ODOT, it was through discussions with ODOT through their financial reports that they provided us with information such as the cost of the other tow plows that they purchased, along with their fuel price. So all of these things were determined using ODOT data. And then for the fuel economy, again, we used the 661 forms. For the speed of the trucks, we used the video data and the GPS AVL systems from the trucks that we had collecting data. Events came from NOAA, labor rates ODOT. So here's a list of those. Again, they're presented in the report if you would like to go into more detail on them. So when we talk about the utilization rate, we wanted to determine how much they were used during each winter event. When you're looking at the utilization rate for the tow plow, it's basically just the time the tow plow is deployed, the amount of time it's deployed during an event, divided by the total time it was out during an event, multiplied by 100 to get a percentage. For the standard truck, again, we use the GPS AVL verifying with 661 information, so the times that they were saying that they were treating, which includes plowing or salting, over the total time they were on the route during the event. And then this was done for each type of weather classification. except no snow. We just looked at trace through heavy. So we looked at it for each snow event, and we looked at it for overall, because we use the overall when we look at the truck efficiency. So overall, the tow plow is utilized 54% of the time, and the standard truck's utilized 65% of the time. Now that's just the average and would make sense because the tow plow can get their routes done more quickly than a standard truck. When you look at trace events, they're very similar because you maybe don't need the tow plow during a trace event. And then as you get to light event, moderate, heavy, you can see the tow plow gets done more quickly than the standard truck. It takes the standard truck more treating loops to get the route clear versus the tow plow. So, yes, and we looked at the utilization rates during the hours of the event, not during the cleanup time after, because that can vary just dramatically on what the operator is wanting to do as far as cleanup. So we just really looked at during that storm event, which included that extra hour, to determine what the utilization rates were. When we get into the truck equivalency, again, like I said, it's not the 1-to-2 ratio because it's not always able to be deployed or needed or necessarily needed to be deployed. So when we look at them, we wanted to set our equivalency. We want to see what the capacity. Sorry, let me just start over here. So we have the capacity of the tow plow times the utilization of the tow plow times the efficiency of the tow plow, and we want to figure out when they're equal. So we set it equal to the capacity of the standard truck, the utilization rate of the standard truck, the efficiency of the standard truck, times the theta. And the theta will be your equivalent number of standard trucks needed to be equal to the tow plow. So when we're looking at this equation, however, the efficiencies of the tow plow and the standard truck are not something that you can easily gather or collect or determine. So using multiple trucks, using multiple tow plows, using multiple standard trucks, we can use the assumption that those two are considered equal, and those two will drop from the equation. So from here you can see once we drop the efficiencies from the equations, we know that the capacity of the tow plow is 2 lanes. We already just saw the table determining the overall utilization rate of the tow plow, setting that equal to the capacity of the standard truck being 1 lane, the overall percentage, overall utilization of the standard truck, and then from there we can calculate what theta is. We use MATLAB to determine theta, so we ran it in a Monte Carlo simulation again. I think we did it 1,000,000 times and it almost crashed one of the computers, but we did let it run and it came out with an overall theta being 1.706. So from that you can say that it takes, from the observed data from this study, it would take the tow plow was doing the work of 1.7 standard trucks. And this is the distribution. You can see it's a very tight one. So we would consider that a good distribution for this. When we look at the annualized cost, again, we're looking at the annualized yearly cost would equal the annualized capital cost, maintenance cost, and operation cost. Here's a sample of the distribution. There's one for the tow plow, there's one for one standard truck, and there's one for the equivalency standard truck presented in the report. So they're all ran 500,000 times. The average cost presented here at $83,629 per year is for the tow plow. Here are the results for the other relationships that we looked at with standard deviations. You can see, so for one standard truck, and remember that our standard truck had the additional wing and 14-foot plow, was $62,212. The equivalent truck, however, came out to be $106,180. So from there you can say that the tow plow compared to the equivalent trucks has a savings of about $22,551 per year. based on the data we observed in this study. If there were to be no savings, if we wanted them to be equal, that's saying that the tow plow needs to do at least 1.4 with 1.4 standard trucks. Again, more data is presented in Chapter 6 of the final report. And then we get into implementation. So when you're looking at whether or not a tow plow is ideal for your area, it is very important to look at what your current routes are and what your current cycle times are for each of your routes. We didn't want to do necessarily a yes, no. We wanted to make sure that there's a lot of factors that play a role in determining whether a tow plow is going to work out in your area or not. And from what we observed, one of the biggest things would be your lane configuration. So how are your routes set up? Are you even able to deploy a tow plow on your routes? If you can't deploy it, it's probably not a good idea to invest in one. However, if you have a lot of multi-lane roads, that would be your first indication of if you think it works for you. We did see from Chapter 5 data for the traffic impact that there is a delay associated with the tow plow. If you're in if you have lanes that have multiple 6 or greater, there might be a passing lane to get through the tow plow. However, when we were looking at the 4-lane divided and portage, there were delays because vehicles couldn't pass it. This also could be you might be okay with that. So when we're looking at the ideal environments for tow plow versus maybe a less ideal environment for a tow plow, again, to reiterate, we talked about lane configuration. Do you have routes where you can actually use a tow plow, where it can actually be deployed and used to its fullest? Next, you want to see, are these routes that you are okay with slowing down traffic and delaying it while the tow plow is deployed? Some county managers throughout this project felt that they like that fact that traffic has to slow down. It allows people not to travel on untreated roads and cause accidents. So those are just different things that you want to keep in mind if you're looking at implementing a tow plow within your fleet. The next one is going to be your weather. So are you going to be able to use it to its fullest? Are you going to be able to use the plowing? If you're just going to use it to treat, is that the best a piece of equipment out there for you? So areas with higher amounts of snowfall would be more ideal for a tow plow versus ones with light snowfall. Through literature reviews and discussions, things like terrain are also important to consider, especially when you're looking at which truck you want to purchase to tow the tow plow. There have been different there's been different surveys for other states that have used it, saying that it's hard to get up some hills, so rolling terrains and flat terrains are more ideal versus maybe the mountainous terrains. That doesn't mean you can't use it, it just means you might need a bigger truck, or you need to just be aware of that when you're looking at a tow plow. Also, turnarounds are another thing to think about, which also came up through the lit review. You want to make sure, do you have a lot of places that the tow plow can actually turn around, or is it more urban and harder for it to maneuver and switch directions? The table on the right kind of just gives a little bit of when you're looking at your snowfall categories and what kind of lanes you have, where tow plow is less ideal in 2-lane areas no matter what your snowfall is, because you're not going to be able to really deploy it. Versus maybe 2-lane with a big shoulder, you can probably deploy it some to help clear off shoulders, and then once you get into the 4 lanes or more, you get into the more better areas that you're going to want, that you might see more of a benefit from having a tow plow within your fleet. This was another table that just a theoretical table we created, which is just looking at potential savings based on the data we observed in our study. For the first top table, we looked at if you got 20 to 25 events per season, 26 to 50 events per season, 51 to 75% events per season, 76 to 100 events per season, and then you can see that the rows consist of what kind of snowfall those events are. So the first one being primary, trace, and light. The next one, primary, light, and moderate, and then moderate, heavy. For this one, we used all the same data that we used to determine the cost for the tow plow. However, we just changed the distribution of snowfall amounts. So those are the only thing that was manipulated out of those equations. So there was multiple random distributions to fall within each one of these categories, and then from there determining a range of what the cost savings could be for the tow plow versus the equivalent 1.7 standard trucks. So you can see that there is still a savings associated even when you do have small and light events, or small amount events, and when they're lighter. However, that doesn't always necessarily mean that it's the best piece of equipment. You want to make sure that you have routes where you could use it. Also, you normally wouldn't design your fleet for the most severe event. You would design it for what you normally want to see. So you just really have to make sure that you look at your routes and if it's realistic, even though there is a cost savings associated with it in the lighter events. And when you look at the table below, the same thing holds true. This is actually just looking at capital cost. So this is if the tow plow is sitting in your parking lot and if the standard truck is sitting in your parking lot. And you can see when you look at one tow plow to 1.7 one equivalency, you get that cost savings just based on capital cost alone of $4,100. However, you cannot purchase 0.71 of a truck. So when we looked at 2 to 3, the tow plow is actually more expensive capital cost, looking at capital cost by $2,200. And if you remember from previously that 1.4 saying that there's no savings, that was using snowfall data. That was trucks going out and being ran. This is just capital cost. So when we looked at the next greatest whole number using the 1 and 1.7, going up to the next closest whole number using those ratios, you get a 7 to 12 ratio. And that one, again, you see that there is the savings with the tow plow of in just capital cost of $30,600. All right, so thank you for your guys' time, and we'll open up for questions.
Okay, we have one question on the webinar right now.
Okay.
And that is from Greg Selstead. He's asking about slide 36. Implementation, you presented ideas for terrain. Do you have specifics in regards to grades associated with rolling versus mountainous? Any additional context to the use of terrain?
That information came from literature reviews. New Hampshire's the one that reported to us that they were having issues on some of their hillier roads. I do not have grade information as far as precise what grade it would work on and what grade it wouldn't. I would recommend, if you're considering it and you're worried about it, to call New Hampshire, talk to people there. Also, I know that the counties and ODOT are more than happy to talk to you about what routes and what terrains they currently have and what trucks they are using to pull the tow plow.
Okay. Do we have any questions from the audio portion? You may unmute your phones and ask them at this time. Greg said thank you.
I saw that little pop-up.
Do we have any questions from anybody in the room?
I know you said the report will probably be out in another 3 weeks to a month. Could we get a copy of the presentation?
That presentation is what will be out in 2 to 3 weeks. The report, we are actually getting it today, so it should be posted within the next week. And it's posted on the ODOT research website. So you can contact us if there aren't any more questions. I want to remind you, as it said in the final slide, that the final report will be on our website, And if you have any additional questions, we can send them to the researchers at research@dot.state.oh.us. We will forward those to the researchers so that you can get answers. Other than that, I hope you've enjoyed this presentation, and it is final.
It's all done.
It's all done.
Thank you.
Thank
guys.
you for your time.